Wow. We're live. There we go. We are live. Okay, so first of all, number one is the easiest question of all. Nobody is going to miss number one. Nobody. I'm not kidding. Number one. I'm going to rewrite it in order. So that one's first, right? 4x cubed. Go ahead, Carly, say it.
4x cubed.
Yes.
Plus 10x squared.
Yes.
Plus 3x minus 5.
Awesome. Okay, everybody agree with that? What's the degree?
3.
You guys are awesome.
Wait, why?
It's the biggest exponent. Good question. Always the biggest exponent, okay? Leading coefficient.
3.
It's 4, because it's the first number. It's leading. It's leading, okay?
Yes.
And that tells us in behavior, okay? Now, how many roots does it have?
3.
3.
Yes, because it's degree 3, so 3 roots. And now P of 2I. Okay, now, you have an I button on these calculus, so we're going to make it easy for you, okay?
Oh, correct.
I'm going to teach you how. So we're going to go 4 2I cubed plus 10 times 2I squared plus 3 times 2I minus 5. How many kids already knew there was an I button on there?
I did.
Good. So it's actually pretty easy. The I button is right down here by the period. Well, it's not a period. This is a math class. It's a decimal, right? It's not a period. Silly me. So I'm going to go 4 parentheses. I'm going to go 2I to the third power, okay? And then I'm going to go plus 10 times 2I squared, right? Plus 3 times 2I, subtract 5, okay? Everybody find the I button? Makes it so much easier. It's down by the period. I mean, not period, I mean decimal point. I said it again. Boom. I got negative 45
Hold on, isn't it?
minus 26I. Awesome. Okay, thumbs up? Yes, Ellie.
Something weird happened.
You have to use the over arrow whenever you Okay, number 2. So we're going to divide. So on number 2, I've got 3x cubed plus 4x minus 1. We're going to divide it by x plus 2. Now there's long division or there's synthetic division. Do you remember? Synthetic's much easier. So we take negative 2, right? Into a 3, a 0, a 4, and a 1, because there is a 0x squared that we didn't write, but we need it because it's a placeholder. Yes, Ellie? What? Yeah, oh gosh, thank you. Once again, I would have made a mistake. Thanks, Ellie. Okay, everybody see why the 0 must be there?
Yes.
Must be a place value, okay? This is my add line, and that's my remainder, okay? Step 1, bring down the first term. Am I going too fast? Slow down for a second. Tanya, how's everybody doing over there? Okay, bring down the first term. I get a 3. And multiply, right? 3 times negative 2 is a negative 6. And add. 0 plus negative 6 is a negative 6. And multiply. Negative 6 times negative 2 is a positive 12. And add. 4 plus 12 is 16. And multiply. 6 times negative 2 is a negative 32. And add. And I get a negative 33. Now the x's were invisible, right? So we bring them back. 1 less degree, because we invisibly divided by x. So this is an x squared, 1 less power. So my answer is a 3x squared minus 6x plus 16. And now I have a remainder, so I'm going to go plus a negative 33 over what I divided by, which is the x plus 2. Okay, I have to,
Would it be negative 33? And would it be minus 33?
yes, yes, both answers are correct. Plus or minus or minus, totally correct. Lauren, absolutely right, okay? So now, is it a factor?
No.
Why do you say no?
Because we just said negative 33.
Remainder is not 0, right? That's the biggie right there. Remainder's not 0, so it's not a factor. How am I doing? You guys can do this, right? Tomorrow you're good? Okay, turn the page. Now, number 3. When you graph, all I need is a sketch of, okay? So I've got p of x equals a negative x squared, x minus 3, x plus 1. Okay, so my zeros are at x equals 0, negative x equals 0, x equals 0, x equals 3, and x equals negative 1. Now I had to count this one twice. I've got to count that one twice. This negative x means nothing. Negative x 0 is still 0, right? Still 0. Or x equals 0, okay? So now here's all I want. I don't care about the heights. I just need the shape in the correct zeros. So this is a double. I'm going to make myself a little note. That's going to be a double root, okay? I need to remember that. So that's a double root. There's a root right there. I'm going to have at 1, 2, 3. I'm going to have one right there, okay? So I'm ready to sketch it, but I have to remember something about end behavior. It's going to finish down. Would you agree? So it's got to finish down. So it's going to look like this. It's going to finish down. This is a double root. So it's going to go through it, back through it again, right? How's that? It doesn't have to be perfect. It has to have the right shape, the correct end behavior, and the correct zeros. Vincent, question?
No, you circled my question.
Okay, good. The negative, right? For end behavior?
Yeah.
Yeah. Okay, 4. How am I doing?
Wait, what's the thing for behavior itself?
Oh, I have to describe it. Thank you. So as x approaches infinity, y approaches negative infinity. So as x is getting bigger and bigger and bigger, y is going to negative infinity. Thank you. And just the opposite. As x approaches negative infinity, as x is getting this direction, y is going to approaches negative infinity. How's that? There you go. That's end behavior. Thanks, Lauren. As x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity, okay? And we use approaches, and you'll do that in calculus also because you can't get to infinity, all right? Okay, number 4. Okay, I need those roots. I've got a x to the 4th minus 2x squared equals 8. Now we know there's 4 answers. Everybody agree? We agree 4 answers? So let's bring over the 8. I'll have an x to the 4th minus 2x squared minus 8 equals 0. I'm just going to factor x squared, right? X squared, x squared. Minus 4, positive 2, and the negative 2x squared is there. When we do our double, smiley, right, it's there. So then, many equations, x squared minus 4 equals 0, and x squared plus 2 equals 0. And I'm going to solve. If I add 4, x squared equals 4. When I square root, I'm going to get 2 answers, so I'm going to get x is equal to plus or minus 2. Don't forget that. I'm going to take a half point off if you can't remember the plus or minus, right? Because we need 4 answers. Minus 2, x squared equals negative 2. Square root. I'm going to have plus or minus square root of 2 I. And that's because I got a square root of 2 and a square root of negative 1, right? So you need the I from the square root of a negative number. And we have 4 answers. How am I doing? Whisk this away in a minute. I'll wait for you. Okay, number 5. I have a 10x cubed plus 5x, 6x squared plus 3. Okay, so I need to bring them all over. I'll have a 10x cubed minus a 6x squared plus a 5x minus 3 equals 0. 4 terms, we're going to group them. 4 terms, let's group them, okay? These two have a common multiple of a 2x squared. Common 2x squared. If I factor out a 2x squared, I'm going to have a 5x minus 3, which is what I have here, but I have to be careful, okay? I need something here. Exactly. See, there's an invisible 1 here, right? So I go plus 1 of 5x minus 3. Okay, I have to have something there. So then, what do they have in common? And we write that once because we pull it out for both, right? And if it helps you to cross it out, okay? What's left over? 2x squared plus 1. Okay, how am I doing? Okay, 1 says good. Now we got our mini equations, 5x minus 3 equals 0, and 2x squared plus 1 equals 0, right? And I'll solve. Plus 3, divide by 5. One of my zeros is 3/5. Minus 1, 2x squared equals negative 1. Divide by 2, I get negative 1/2. Square root, I get x equals plus or minus the square root of 1/2 I. And I think you know I'm getting the I from. The I comes from right here. Right, do we agree with that? Okay. Am I doing okay? We'll do 6 in a second. So 6 says when p of x is divided by 2x plus 1, it's like the answer is this, the quotient is this, with the remainder 5. What's p of x? What's the original question? So this is the one that I like to show and ask you what goes here. What goes here? 31, right? You guys agree? We agree? 5 goes into something 6 times with 1 left over, and so to get back, you went that times that, then add that in, right? Same process in 6. We're going to take our 2x plus 1 times our x squared plus 3x minus 4, and then we're going to add in our 5. Okay, so here we go. We're going to multiply. 2x times x squared is 2x cubed. 2x times 3x is a positive 6x squared. 2x times negative 4 is a negative 8x. All right, now we'll do the 1. 1 times x squared is a 1x squared. I like to line them up, just makes it easier for me. 1 times 3x is a positive 3x. 1 times negative 4 is a negative 4. Bring down the plus 5. Now we're almost done. 2x cubed plus 7x squared minus 5x plus 1 is the original polynomial with this answer when it's divided by that with the remainder 5. How am I doing? Okay, turn the page. 7. Did I go too fast? Jose, did I go too fast?
No, I got it.
Are you good?
Yeah.
Okay. It's not my job to confuse you, so if you want me to slow down, I will, okay? Okay, 7. Well, it's a cubic, right? And it's got a root of x equals 4 and a root of x equals 2 plus the square root of 3i. But it needs one more root because it's cubic. It needs, yeah, exactly. So my other root is going to be my 2 minus the square root of 3i, right? Okay, so part of this is actually pretty easy. The first part, we'll say p of x for polynomial. P of x, polynomial with respect to x, is equal to x minus 4. Okay, that happens to be, you know, that piece there, right? And then, well, these two are kind of hard to do, but we have that equation, x squared minus the sum of the roots times x plus the product. So if you were absent yesterday, I'll go through this slowly. Juan, Jose, were you guys gone yesterday?
No, Alex.
You were, Alex was, right? Juan and Alex. So sum. Sum means to add. So I'm going to take my 2 roots, I'm going to add them. Okay, sum means to add them. And I get 4, and then these two just cancel. So here's what I know so far from my answer. An x squared minus a 4x. The product. I don't know what the product is, so the product means to multiply. So I'm going to take my 2 roots, 2 plus the square root of 3i times a 2 minus the square root of 3i, and I'm going to multiply, okay? And then what I get, I'll put plus right there. So I get a 4, 2 times a negative square root of 3i. Carly, that is a negative 2 square root of 3i, right? You asked that earlier, right?
I did ask that earlier.
And
Wow.
the same thing. We're going to get a positive 2 square root of 3i, right? When I go 2 times square root of 3i. And then I get minus, square root of 3 times square root of 3 is 9. I times I is I squared. Okay? Square root of 3 times square root of 3 is square root of 9. I times I is I squared. Okay, see what I have. Now, first of all, these two middle terms are going to cancel. Boom, boom, gone. They're supposed to. I'm going to have a 4 minus a 3 times a negative 1. Okay, square root of 9 is 3. I squared is a negative 1, which is really 4 plus 3, right? Double negative, which is 7. So I go plus 7 there. So this polynomial will give me all 3 of these roots. I would need the quadratic formula to get these 2. Okay, how am I doing? Okay, can you do that tomorrow?
You don't used to like point it out.
No, please don't. Yes, you can. I would not. Absolutely, you can. I'm not going to, Ellie, because I would make a mistake. Okay. So I'm gonna leave it like that. I feel like, whew, now I got the right answer. I'm not gonna mess it up. Okay. Okay, number 10. Okay, number 10. We got a dog pen. For dogs, cats, and birds. Wow, I got to keep the birds away from the cats, the dogs away from the cats, the birds away from the dogs. So we got to keep them all separate, don't we? And to save on fencing, we're going to put them all against the barn, right? So we've got 100 meter of fencing. I know I'm going to put some fencing here, 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 and here, right? So if I put fencing here, here, and here, and here, what's left over to put on the length is the 100 minus the 4 W's, right? Well, it says we want to find the dimensions that maximize area. Maximize area. So I know area is length times width. which would be 100 minus 4w times the width, which is w. So area with respect to the width is a 100w minus a 4w squared. How am I doing? Am I going too fast? I'll slow down for a second. So that's 1 point on this. So you got the formula. Awesome. And Ellie, this time I did multiply it out because I want to next use the negative b over 2a. So that's why I multiplied it out, right? So if I want to maximize or minimize, it would be the vertex on a graph. I mean, this thing would graph, and we'd have a parabola. It would be the vertex. So I'm going to use my negative b over 2a. So there's my b, there's my a. So I'm going to go, okay, it's going to equal my negative b, which is negative 100, over 2 times my a, which is negative 4, 100 over 8. What is it, 12.5? Is that 12.5? Yeah. So that means I'm going to go back to my fence. And if I make my fence 12.5, 12.5, 12.5, 12.5, right? And then the length, let's see, I'm going to put 12.45 there. I'm going to go 100 minus 4 times 12.5. 100 minus 50? I think it's 50, which is 50, okay? So I'm going to build my fence, and it's going to be 12.5 by 50 meters. Okay? How about the domain? Okay, we're going to use some common sense. Domain is the width. Domain is the width. So we can build any fence we want with some restrictions, right? The smallest the width could be is up to 0, right? We're going to build this thing. It'd be super long, but not very wide. So it could be close to 0. And if I take my 100 meters and put all of it here, here, and here, it'd be super long, but super skinny, right? So if we went 25, 25, 25, 25, we'd use up all of our fencing. How's that? Does that make sense? Okay, and last but not least, let's look at the, oh, that's it. And the extra, we've done this one. I'll set you up on the extra. Okay, I'll set you up. X 200 minus 2x divided by 2, 100 minus x. We roll it up. We've done this one, right? X 100 minus x. Volume is pi r squared h. Circumference is 2 pi r. You need to get everything that's in terms of x's and then use your graphics calculator, okay? And if we've done that one, it's somewhere in your notes if you guys want to look it up, okay? All right, that's all she wrote. And then we got a little bit of an assignment we can work on together outside. Page 93, 1 through 7.